Hello everyone. In our last video, we have seen how to solve a homogeneous differential equation. Today's class, we are going to learn how to form a linear differential equation and hence get the general solution of such linear differential equations. First, how do we identify whether a given differential equation is linear or not? Now, suppose any differential equation, which is of the form dy by dx plus p into y is equal to q, where p and q are constants or are functions of x only, are called as linear differential equation. I repeat, any differential equation which is of the form dy by dx plus p into y is equal to q, where p and q are constants or are the functions of x only, are called as linear differential equation. If I am able to write a given differential equation in this form, then such differential equations are called as linear differential equations. Before we solve a linear differential equation, we will have to bring the differential equation in the linear form, then follow the steps. Now let us first see what are the steps to solve a linear differential equation. The first and the foremost step is I need to bring the given differential equation in the form dy by dx plus p is equal to y in the standard format. This is standard format where p and q are constants or they are the functions of x only. Or sometimes if I have been given dx by dy, then it will become px is equal to q. Just make difference of these two. Whenever my differential equation in dy by dx form, then I should have the standard different linear differential equation in the form dy by dx plus p into y is equal to q. But in case if my given differential equation is in the form dx by dy, then my differential equation to be written in linear form will be dx by dy plus p into x is equal to q. Again, here p and q are constants. Here also p and q are constants. Because there is a difference in this, we use one more term telling that they are here. Whenever my differential equation is in the form dy by dx, then p and q are functions of x only. Whereas when the differential equation in the form of dx by dy, then here p and q are the functions of y only. So this is the only difference that we'll have to identify. Once I am ready with my standard format of linear differential equation, the second step is I will have to find something called as integrating factor, which is given by e to the power p into dx for these kinds of differential equations. In case if my differential equation is dx by dy form, then my integrating factor will be written as e to the power integration p into dy. X changes to y changes to x. That is the only difference when the differential equation is in the form of dy by dx or dx by dy. This is the only difference you'll have to identify. Once I'm able to get the integrating factor, then my final step will be the general solution of the differential equation given by y into integrating factor is equal to integration q into integrating factor dx. This is for the differential equation in the form dy by dx plus py is equal to q. If the differential equation is linear and it is in the form of dx by dy, then such linear equations general solution is given as x into integrating factor is equal to integration q into integrating factor, but integrated with respect to y. So this is the only difference that you need to take care. Hence, once I am able to arrive at this point, integrate, get the value, you will get the linear differential equation as required. Let us take up a simple example. I have been given a differential equation which is in the form dy by dx minus y is equal to cos x. My question, remember, nowhere you will be told that whether it is a homogeneous differential equation or it is a linear differential equation. Looking at the question, you will have to identify which is a homogeneous function, which is a linear differential equation. Remember our last class, we had told homogeneous differential equation is a equation if the given function f of x comma y can be written in the form of degree 0 to the power 0. Any differential equation with degree 0 is said to be homogeneous. Therefore, once we are arrived at homogeneous, then we put the substitution y is equal to v into x, that is homogeneous. But here, to form linear, it should be in the form dy by dx plus pq equal to q. So this is something in the form of dy by dx plus p into y is equal to q, where on comparing these two, in place of y it is y, so therefore p is equal to minus 1, q is equal to cos x. So my first step, that is, I have brought the given differential equation and I have written the values of p and q. The next step is, second step is, I'll have to write the integrating factor. So integrating factor is equal to e to the power integration p into dx, that is e to the power integral p is minus 1 dx, that is e to the power minus integration dx, that is e to the power minus x. This is my integrating factor. Once my integrating factor is ready, the next step is the writing the general solution. So how do I write the